All right, you're going to pull out your P. What's your Q? Everybody okay with that? Did you do the test? Did they pass?
Yeah.
Okay, they passed the test. So now you can find your mean, which you found if you tested this guy. And what was your mean?
42.7.
42.7. And then you can find your standard deviation. You've got the 42.7, multiply it by the 0.39, take the square root, and what's your standard deviation? You have to know this for your z-score formula. 4.0? Oh, wait. Thank you. Okay. Now, your probability statement. This is important. What is the probability that more than 50? How do I say more than 50? More than 50. We say greater than. So here's 50. Do I use 50?
Yeah. Or no.
If you have more than $50, you have more. So I'm going to start at 51. And I'm going to go up. Is that my lower end or my upper end? Lower. So we subtract 0.5 from your lower end. So x off of this lower end. So x is greater than 50.5. Will I ever hit a 50.5? No, but that's what makes my continuity the bars come in between. And that's my correction for my continuity, because these are discrete values. Otherwise they come at each bar and you get gaps. So this kind of fills that gap. It just makes it statistically correct. Now, once we're here, we do everything else the same. Here's your mean. Your mean is what you found, 42.7. 50.5, somewhere here, and we want more than. Is it going to be less than 50% or greater than 50%? Less. So therefore, when I look up when I find the z-score and I look up the area, what am I going to have to do to the area? Subtract it from 1, because I need the right side. Good. So we go back to your z-score formula.
You use 50.5 that you're looking for.
That's your x now. This becomes your x. So 50.5 minus 42.7 over your standard deviation. This will give you your z-score. Now you expect your z-score to be positive, and you should get 1.91. Good. Okay, you look that up. You find your area, 0.9719. Now if I look this up, could this possibly be 97% out here? You got to subtract it from 1. Good. And what do you end up with? 0.0281. So there's about a 3% chance that if I randomly select 70 people, that more than 50 of them will respond yes. There's about a 3% chance that more than 50 will say yes. Okay? Interpret this as well, because this is where we put these two, scenarios here. Also, like again, whenever you see the source code, they take this from a valid source. Notice this one came from Marist College, Institute for Public Opinion. It probably is not on Marist College. Okay, are we good with this? Okay. Couple of things to do, remember. Okay. Let's try one more. I think I'll do the in-between. We'll go for one more. We'll do an in-between.
Miss, did you hear the new theory about the Malaysian plane?
About the plane? Exactly's work a little bit different than the other ones do. When you have it exactly, it's not like finding just one number. We got to work the whole bar. We have to expand your bar. So I jump to example 5. A survey reports that 95% of internet users use Microsoft Internet Explorer as their browser. So 95%. What's Q?
0.05.
0.05. Good. You randomly select 200 users.
That's your N.
That's your N. And you ask them whether or not he or she uses Microsoft Internet Explorer as their browser. What is the probability that exactly 194 say yes? Yes? Question?
No, I'm just saying.
Probability that it's exactly 194.
Why are we doing equal to
Exactly what I'm
Because you
saying.
only want, they exactly say 194.
If nothing changed though, it's just that's the only thing changed.
Yeah, we're going to have to change it a little bit because our rule is we drop it 0.5 on the low end, we add a 0.5 on the upper end. We have to make a bar out of this 194. Here's 194 all by itself. And here's 195. You have to bring this bar out halfway. And here's 193. You have to bring that bar halfway. That 194 is just this little piece right here. Because this is a discrete value. So for the exactly, you have to bring this bar out. You have to drop it 0.5, you have to raise it 0.5. So technically, it's going to look like this. 193.5 to 194.5. I need the full bar because it's just a discrete value. So it's one little line on your graph, which is really kind of hard to measure. So I need to measure a bar. Remember, your bars, technically your bars will go like this. This is what you approximate to your normal curve. Once we use your n times p, your n times q, we know we approximated a normal curve. So we got to use this bar thing in here. So the exactly's work a little bit differently than just making a table, finding the exactly that problem. So again, we check for n times p, we check for n times q. And I can tell you that they both work. If they didn't, we wouldn't be able to do this problem, so we can figure it out from there. So first thing we do is find your mean. The one you would have to worry about is the 0.05. So 0.05 times 20 times 200 will give you 10. So you're okay with check your lower one, because the lower one, if that works, so does the upper one work. So we go for the mean. I'm on page 264. So we find your mean to be 190. Then we find your standard deviation. 190 times 0.05. And we take its square root, and we find it to be 3.08. Now, to do an in-between, you have to do the lower one, find the z-score, upper one, find the z-score, find the areas, subtract it. If you do your normal CDF, you can do your lower limit, your upper limit. You can do that on the calculator. It bypasses all of that.
3.08.
3.08. So we're going to do one for 193.5 and one for 194.5. Remember, we just had to expand the bar on this exactly because he was just a little line like this. Because it's exactly one number. So we expanded that bar to fit right in here. I exaggerated the size, of course, because here's 193, here's 195. When you do their bars, they will go like this. So we expand their bars to fit in. So we're going to do your z-square for this guy. X minus the mean over the standard deviation. And then we're going to do it for this guy. X minus the mean over the standard deviation. Never ever subtract your z-scores. Never ever add 1 to your z-scores. Or subtract from 1. So we find the first one. 1.4. Got it. This one?
Yeah.
1.46.
That one.
Okay. Now, find your areas for these guys. Your areas for these guys . Okay, you want to subtract your areas so that your areas are positive. Areas cannot be negative. When you subtract them, you find the probability that it is exactly 194. So it's about a 6% chance that, a 6% probability that out of the 200 users, exactly 194 will say yes. It's very hard to get an exactly. If you got 195, it's close, but it's not exactly. So the exactly usually has a very small percentage. It has a very small bar, just one little bar, one little piece of area. That's all it is. So that has to be a really small number. In the next unit, when we get into your confidence intervals, we'll see what we do for your confidence intervals, giving it a plus or minus margin of error, so you have a little bit more leeway when you use an exactly. So everybody okay with this? The exactly's, you got to expand it. It's got to be a bar. Excuse me. All right, so let's have you try the next one. From the same thing. So now it's just this probability. So you keep the same mean and the same standard deviation. Okay, just expand your bar for your exactly, and you work out your z-scores. If you use your calculator, this is a great one to do on your calculator with the in-between. Find your mean, your standard deviation, and do the lower limit, the low end of the bar, the upper limit, the high end of the bar. So anybody would like to come up and do this?
Taylor, fine.
Come on, there you go.
Got this, man.
Give us your new probability statement
I
too.
like surface.
Come on, you can do it, Dennis.
It's safe, right?
Come on, you said fine. You do not have stage fright.
Well, how do you want to start off?
Oh, you can get rid of this line. I'm sorry. I was going to do it. Start off with your new probability statement.
Oh. You think, guys?
No, that's not it.
What was it?
Inequalities.
Guys,
Yeah.
he did absolutely fine. He was setting it up so he could do
Yeah,
his
guys, I
Z-scores.
ain't finished.
No.
There you go. He was setting it up to do his
How do I get more
Z-scores.
room on
Be
it?
patient.
Gunner, you're writing too big. You want?
Yeah, no. How do I get more room on the bottom?
It'll erase it. I don't have it so that it could go down. But just do your Z-scores here and here. There you go.
Don't tell me what to do with it. What's my that calculator? Joey. Excuse me?
190 is your mean.
Mean guy.
I thought the mean was 200. Oh, that's why my answer is wrong.
Mm-hmm.
The end was the 200.
Which one you got, Taylor?
0.16.
This is called stability.
0.16. And the other one's 0.49.
they're both close to the mean, right? So they're both close.
0.5637.
What's the nine? It's 12.
Ooh.
0.6879.
Excuse me?
0.6879.
That's good
I
that
need
you
more
can
room.
delegate for this. You got one more step to do.
And
No, but-
subtract them.
Yeah, I know that. Not
One more
just
step.
saying
You'll fit it.
It's right here.
What?
Let's stop working on that
Look,
part, isn't
right
it?
there. I'm not putting
Just
up
write
there.
it.
He's doing great.
I'm the teacher here. Isn't it annoying when everyone yells at you?
0.1243.
Yeah.
No, I hate it. So I don't do this
Yeah.
stuff.
0.1243.
I give about 12%.
Good. Very good. Good work. So it's about 12% chance that 191 people will say yes. It's a little bit